Alright, we want to speak for a few minutes about a process called hematopoiesis. And hematopoiesis is a process, or at least a general process, by which all of the formed elements, all of the cells and cell fragments of blood will be formed. The first thing I want to say about this process is that you should keep in mind that it pretty much begins for all of the formed elements within red bone marrow. Now the process can complete itself in different locations, but for all of those formed elements, once again, it begins in red bone marrow. If we take a look at red bone marrow, you're going to find the presence of a cell called a pluripotent stem cell. And this pluripotent stem cell has the ability to become all of the formed elements respectively. If you know, or if you've heard anything about molecular biology before, you may already know that stem cells are basically undifferentiated cells. Now, in order to cause that pluripotent stem cell to become any one particular formed element, that being a red blood cell, white blood cell, or even a platelet, various chemical messengers are needed. And these chemical messengers usually take the form of hormones. And these hormones influence that pluripotent stem cell to become whatever formed element may be needed by the body at that time. Now, after the pluripotent stem cell decides, or rather when your body needs the pluripotent stem cell to become one of the formed elements, that pluripotent stem cell has two options. It can either become a myeloid stem cell or a lymphoid stem cell. Now, once you've taken that step of differentiation, the options are a little bit more limited. Let's deal with the items or the formed elements that arise from the myeloid stem cell line first. If we look at those arising from the myeloid stem cell line, you'll see it pretty much includes almost every formed element. The red blood cells come from the myeloid stem cell. The platelets also. Most of the white blood cells. You got the eosinophil, basophil, neutrophil, and monocyte all arising from that myeloid stem cell. You can even see that they've included in the chart some of these chemical messengers. They're called colony-forming units. So you have, for instance, CFUE, which is colony-forming unit erythrocyte, CFU-MEG, which is colony-forming unit megakaryocyte, and the list will go on. Now, you don't have to keep in mind those chemical messengers, but what you should definitely keep in mind is what you can get from the myeloid stem cell. And that's going to be, once again, a red blood cell, platelets, and 4 out of the 5 white blood cells, eosinophils, basophils, neutrophils, and also monocytes. Now, if we take a look at what arises from the lymphoid stem cell line, a little bit fewer options when you start to take a look at it. First up, lymphoid stem cells only give rise to lymphocytes. And within the body, we're going to see 3 different types of lymphocytes. You have T lymphocytes, known as T cells, B lymphocytes, known as B cells, and then you also have natural killer cells, known as NK cells. Now, we'll talk more about those lymphocytes and the differences and how they work a little bit later, but the key point to take away for right now, from that lymphoid stem cell line, you're only going to get lymphocytes. Now, there are some stages in the development of several of these, or rather a couple of these formed elements that we'll take a look at, or at least recap here a little bit later on in the discussion. But you can see that there's a process by which those red blood cells have to be formed. They go through a stepwise process where they first would, after the myeloid stem cell, become a proerythroblast. Whenever you see a cell that has a blast at the end of it as a suffix, you have to understand that that cell is eventually, hopefully, going to become a mature cell. When it becomes a mature cell, we put CYTE, site, at the end of it. So proerythroblasts are formed due to the presence of colony-forming unit erythrocyte. Once we have the proerythroblast, it continues to mature. The proerythroblast will be acted upon by a hormone that you've heard of before called erythropoietin. And erythropoietin will cause that proerythroblast to become a reticulocyte. The reticulocytes would be released into blood from red bone marrow. And it's at this stage that the red blood cells would begin to lose their nucleus, or they would eject that nucleus, and in the blood they would take that final step of becoming a mature erythrocyte. We can also see that the platelets have a kind of a lineage to go through as well. The CFU-MEG, the colony-forming unit megakaryocyte, is going to cause the megakaryoblast to become a mature megakaryocyte. And then this megakaryocyte breaks apart and yields platelets. Now, if you recall our discussion about formed elements, we said that we had to have, or rather phrase formed elements as being cells and cell fragments. So these platelets are cell fragments. They're fragments of that cell that you see there on the screen, a megakaryocyte. So this is a lineage. Basically, this is a story, obviously, of hematopoiesis. That's the formation of the formed elements, essentially. And I want you to definitely keep in mind that all those formed elements come from the pluripotent stem cell, that this process begins for all of the formed elements within red bone marrow. Once that pluripotent stem cell is started along the path of differentiation, it either becomes a myeloid stem cell or a lymphoid stem cell. And then you should keep in mind what arises from the myeloid, and then also what arises from the lymphoid stem cell.